yesterday, right? Okay, we left off in this. So you want to realize that in chapter 3, the beginning part of chapter 3 is actually all actually revisional. As in, you are going back to where we were. What you did in the lower year, you did all the integration stuff, and we are just trying to revise the integration techniques. Okay, example 3. Let's hear from Wen Yu. Quiet. Wen Yu. Apparently, do you realize that her name is spelled with a double N? Yes. Why? I'm just curious. Okay. Usually it's one N, but yours is double N. Okay, Wen Yu. What do you say? Alright, she said this now. Right, you said this, right? Next one. Shh. Loudly and confidently. When you. You're annoying her. That's why she's not talking. Thank you. Do you get something? Okay. Right, so these are all the basic. Did I tell you that you need to actually memorize a lot of formulae, you know? Right? Off the cuff, how would you integrate tangent square? Yes. How would you integrate tangent square? Nope. Next. Nope. Next. Okay, let's get those who are in wrong dress code. Hey, Lawrence. Simi, you saying? Brilliant! Okay, so you can remain entire. But I'm not sure that if you go for later on the assembly, the CC hour, right? You'll be picked up, you know, right? Yeah, no time, you got to eat lunch. Okay. It's just a memorize some of this way of doing things, lah. Over here, right? Over here. Okay. It is all about memory work, you know. It's all about memory work. Like say for example, if I say E sharp, one tail, example 4, it will sing up the solution here. Yeah, sing up the solution.
Oh, there's an A sharp minor flat.
Press on. Go on, E sharp. -2 cosine x. If I ask you, how do you know it's like that? E sharp, what would you say? His name, right? Isra. Okay, Isra, sorry. Isra. Okay. Why is the answer like that? Because you will say you have memorized the formula, right? Yeah. It's a no-brainer, no? You just need to memorize some of this standard formula. There's no choice. If you choose not to memorize them, then in the exam you'll be scratching your head, you know. Okay. I gave you the formula formula 1, 2, 3, 4, 5, 6, 7 before, right? Remember? I given you. Yeah. I'm sure you have already memorized them. What happened to you, Rayson? Okay. Usually for this kind of thing, right, when there's involved a x plus b, right, you want to know that in this e to the power of ax plus b, which is a simple formula that you learn in the lower year, there's a formula that looks this way. This is a simpler version of the Formula 5 that I wrote down for you last time. Let's see, Rayson, what was my Formula 5? Without opening the book. Shh. Let's see if Rayson can recall. Let's test his memory power. What did I write for Formula 5? I wrote something like this. And what else? Formula 5 is a more general form of the red color. Right. And then this gives you? Right. And then you see I've seen students doing this, no? And I've seen students, doing cannot, right? Doing the cannot. It's not correct, no. That's wrong, no. That's wrong. The red color formula only works when it's linear. Okay? When it's linear. So for this one, you will have e to the 3x it won't work. Green color. Okay. Sorry. Thank you. It's over 3. Right. By the way, the green color cannot be done, no? At least not I know of, okay? Analytically cannot be done. Okay, for that exclamation, can you tell me, Ethan, what is part 2? Shh.
Part 2.
Part 2.
Alright, so
Say.
ax 2 to the power x over something.
Over?
Ln 1, 2. Yay, I'm correct.
Yeah. If I ask you to provide a proof for this can be proven quite readily, you know. Integrating 2 to the power x, right, can be written as integrating e to the power ln 2 to the power x. And then the e power x ln 2, right? The e power x ln 2 is simply 2 to the power x. That's right. Okay. Let me make it smaller so you can see it in totality. You realize it's all what you did in the lower years, like in year 3, right? Year 3 or year 4, right? Okay, for part 3, right? Let's hear from Hao Wen behind. How do you do a part 3?
I use my MA 3132 knowledge.
Okay, and which is off the cuff, please. Hao Wen.
Wrong sir.
Hao Wen.
1/4.
Brilliant.
Sine inverse.
Wow. And how do you know it's like that?
16x squared is 4x.
Right, 4x whole squared. Brilliant. It's all memory work now. It's a no-brainer thing. The more you remember, the better you are. Right? For integration, it's true. Bio is about memory, what is that? Not exactly that. You need some logic, like how the blood circulates around the body, You got the vein, you got the arteries, right? I think there's some logic in it. It's not totally memory work. As a student in secondary school, Sec 4, right? I got an A1 for bio, but I wouldn't dare do bio again in JC, Yeah. Okay. Example 6 illustrates to you something that is incorrect. This is a common mistake, no? That formula that you know of. What is the formula that you know of? The formula that you know of, which is this, only works when the inside is linear, right? Only works when it's linear. So when it's linear, we all know that this is right. This is example 6. Hey, by the way, our grade task 2 is Monday, no? Next Monday, no? So okay, let's get Chap. Is he? Yeah, he's not here today. I know that he and who else are not here? Who? Oh, they are having some event, right? Yeah. Aditi is personal, is it? Okay. Yeah, she said about a wedding or something like that. Okay, not her mom wedding. Just kidding. Because she said, because I remember a wedding, but the first one that came from her mom. Before she finished it, I got a shock. Okay, jump scare. Okay. Let's hear from Ivan. 1 kill. Come. Right. 2x minus 1 to the power over. Brilliant. Part 2. Continue. Push it. This one uses formula A3. Formula 3. Huh? You can do this, no? You can put a minus here, so that you can then use this formula that I wrote down as formula 3. Do you remember the formula 3 that we had? What is this? Shh, Ivan? Yeah, lon. Okay. This one no lon, no lon. Right. So therefore this one will be minus twice of Ivan. Press on. One more. Brilliant. Over 3, that's right. In my school days, right, we will use textbook in the lower years, no, textbook. And then our teacher made us do every question in the textbook. Every question, you know. They have a lot of exercises. We did every single question in the book. But he doesn't mark. All he will do is show him that we have done it. No, the textbook exercise is a lot. No? They run the pages on it. No, the tutorials very short. Except for the one time. So for this kind of question, because we did it a lot of times, it get into our head, you know. I remember that teacher who taught us that part of math, right? I remember him as a teacher who was a discipline master, but he smokes, you know. He smoked, you know. But because in the old days he started smoking, I don't know how, you know. But when his teacher still smoked, we know like he smoked, you know. And he died of cancer, like you know, later on died of cancer. Yeah. And number 6 is an illustration to you that is wrong. Sure. To provide a correct solution, Yu Tong says she's going to the board and write for us. Okay, Yu Tong, please. Okay, Yu Tong is going to march to the board and with one hand, please. This. Okay, Yu Tong is going to try on the board. Example 6, the correct solution. Yu Tong, please.
Maybe can do something, I don't know.
Anyone wants to give a prompting to her? Yeah, right. Yeah. It is about the only way.
Can you all please like turn off your phone notifications?
Okay. Yu Tong is doing the expansion, you know. So in case you need some help, you know, help is there.
You know the screen. Do we have the AS?
Yeah, for this question, I do not know of a better way, you know.
Why can't you use it?
Use what?
Why can't you use it? Oh, it's not.
Yeah, must be linear. This one requires to be linear.
Oh.
Linear then can.
Wait, but what they ask you to integrate x cubed plus 1 to the 100?
Okay, then turn over to next question, you know.
I'm gonna pretend I didn't see that.
Yeah. It's okay, Ken, I take care of it, Yu Tong, thanks. So she has the idea correct. She has the correct idea. She said to expand. So if you expand using the red color, you will get the, you expand using red color, you get the blue. And then from the blue, you do the term-wise integration, right? So this question is done in this manner. I don't think there's any other way about it, you know. Remind me to let you off early, no, because you all need to eat lunch, right? A good lunch. Yeah, it's okay. It's okay. You want to be very familiar with this red color, no? We learned this in year 3? Year 3, yeah? Year 3. Right. Okay. Yin. 1 kill. Do a 1 kill for part 1 and part 2. No. No. One over.
What is going on?
Sine inverse. And then it is bx over a.
Brilliant. Next one.
Next one is 1 over a times b.
Wow.
And then tangent inverse bx over a.
Right.
Oh my goodness.
Okay, he knows his work. Right. It's all memory work. It's all memory work. So with this in mind, Tae-yun, right? Okay, 1 kill. Right? Right. Next one. How do you approach the next one? Huh? So this question requires you to what? Tae-yun, part 2. What do you need to do? Right, so after completing a square, go on. Okay, so on the screen. There are various ways to go about it. You just do it the way you used to do it. You need me to go through completing the square?
Yes.
Sure. To complete square, right? To complete square, the rule goes this way, you know. If it's a minus x square, you must always take a minus first, you know. And the way to go about it is, x squared now becomes x. If it's minus 8, right? Half of minus 8 is what? Minus 4. And you always minus the square of the second number. Then this one becomes 4 square. This is how computing square is done. Typically. So, Tae Yun, with the computer square form done for you, tell me your answer. 1 over 没有 don't have 1 over 4, no. Only the tangent inverse will have the 1 over 4, but sine inverse 没有 Great. Okay, same David, let's take us through. How do you do a question like this? Brilliant. So this becomes, I typically just do the reverse now, just think reverse. I just think reverse.
How you get that? That's so insane.
What I do is, if it's 4x squared, I will know that it's 2x, because square root of 4x squared is 2x. Then, you think reverse, right? In thinking reverse, it is half, not twice. In expanding, right, you say twice the first and second. In the reverse order will be half, instead of times, you divide by the first. So half the minus 4, which is minus 2, and then divide by the first. The first is 2. So it's minus 4 divided by 2 is minus 2, divided by 2 is minus 1. So then once you have the complex square form, they will press on. Good. Brilliant. You learn well, not bad.
You're sick.
Got 2 ways of saying the word you're sick. Literally ill. Or otherwise, no. Tingwei is on the screen. You can't see,
Tingwei on the screen.
She's copying the previous thing.
Oh, she was busy texting. It's a modern age problem. Even at home, my daughter has the same problem. I talk to her, she just ignore me. She texts. My daughter told me there's one friend that she has in school who only communicate with the parents through text messages. No? Even though they're in the house, right? She told me they will text each other even though they're in the house. No? Do you all do that at home? It's quite epic, isn't it? I think. I hope it doesn't happen to any of you. Okay.
It's quite tragic. You need to think interactions at your home.
Yeah. There is a book that I read before, a short story. It's called The Machine Stops. It describes a world where everything is controlled by machines, you know. Then when the machine stops, everything crumbled, you know. Yeah. The machine stops. It was a short story that I read up before. The machine stops. I think the author who wrote the book is very got very good foresight, that the world is going to be controlled by machines eventually. I think so, no. Everything is digital these days, even teaching. Okay. This formula was discussed before. And what happened on this page, right? It gives you the justifications. It tells you whether or not it's a whether or not it's plus or minus for fx, right? It will in the end turn out to be just modulus, ln of modulus fx, and the proof is provided here, no? It shows you both cases. Eh? It's not written there. Okay. Okay, yeah, hence the result follows. So what result follows, no? The result that this is like that. Okay, so this was my formula 2, no? Formula 2. Okay, let's press on. Next one is, okay, Jun Xiao. Is it Jun Xiao? Jun Xiao. Okay, Jun Xiao. Jun Xiao. Take us through 1Q. The first one is formula 2. What do you have?
He has
Right. Jun Xiao, press on. Cotangent is actually cos over sine, is it? For this case, the part 1, right, the modulus is optional because x squared plus 1 is already positive. Yep. Jun Xiao. What is it? How about next one? For next one, right, Jun Xiao, say part 3. You need a 4 here and a 1/4 here. And Jun Xiao, say. Right. You're hungry, Okay, we target what time? 呃 I think like true, but I think the blue brackets like better, going to be very precise. It won't be marked wrong, it won't be marked wrong. Whether you use modulus or the blue brackets, right? Yeah, thanks for pointing out. No? Because sine 4x is at most negative 1, is it? You're right. Okay, Jun Xiao. Let's invite Jun Xiao to the board because Jun Xiao didn't say much, So I like to hear his voice or his work. So Jun Xiao can march to the board and with one arm, with one hand. And in the meantime, for the rest of you, you have to try this question. It's worth the while. You can do part 4. I take a look, Not bad, you know your work.
wrong lah. What are you doing? Why is it not like this? More than a 3x.
Can. Right. Yes, buddy. Right. Oh, no, no, no. But you can bring a nice screw. If this is going to be a side working, first you cut it as a side working so that easy thing. No close it.
Hey, that's wrong, that's wrong. That's wrong. That's standard.
What you doing?
That's standard. That's standard.
Okay, so you copy the square on the right side.
Oh my god.
But I just let you know, just that you write properly on my hand. I see the working on that. Let's see. Right.
Hey, you still got it wrong.
This question, I see if I go down to see what you're doing, right? Some can, some still struggling. Okay, just okay. You finish it, yeah? Yeah, I think he's almost right. Almost. Not sure. He's almost right.
Can I add a bit of thing to make it right?
Yes, please. Ryan, the savior. There's a song called I Swear. No? Yeah, there is. It's quite a nice song actually, but not very no, not very religious song. Yeah. Go on. Warm. I think warm. Warm. Okay, part 4. Ryan, write in Chinese. 此处是个任意常数。哦，此处 C 是个任意常数。哇哦。Yeah. Who taught you this? This is new to us last year. This is new. Oh, her Chinese are damn good, you know. 此处 C 是个任意常数。Okay, for the non-Chinese speaking, let's do it together. Okay.
I haven't spoken Chinese in like 1 year.
1 year. Apparently, Mrs. Liu joined the school the same day as me.
Whoa!
We came together.
NUS had buddies then.
Yeah, we kind of we joined the school together on the same day.
Hey, we joined the same day too.
Oh my god! Man.
Liu, Mrs. Liu. Okay, the next one will involve the partial fractions. The next one involves the partial fractions. Do you still remember the partial fraction for this?
No.
First and foremost, do you think so? Grayson, what is a partial fraction for this? Right. He says the form of the partial fraction is, and then Grayson is going to take us through to find A, B, and C quickly. is an improper fraction, you know. It is an improper fraction. Okay. Huh? Sure. Okay, reason is here to show you. No need, you know, if you got good eyesight, Ethan, you see that this is actually, wow, Ding Hui very clever.
Hello. How you do that? That is micro.
Okay, Rayson, do it.
I'm not doing long.
No need, no. Ray.
What's the rate?
Huh?
What do you find the rate?
If you do long division, it's worse off, you know. You should try not to do long division. Okay, you should actually do it like this. Equate like this, and then do it without long division.
How?
A is 1.
How is it?
You just take the highest power, which is x squared, divide by the highest power, which is x squared. So A is 1.
Wow.
That's actually a trick. Okay. Then you can use Carrot rule to find your B and C, you know. To get the A, right? To get the A, you just take x squared, whatever x squared you have, divide by x squared. Yeah. To get B, right? To get B, right? You put x at 0 and cover x. No. Covers 1. So put x at 0, you get what? Yeah, negative half. The top is 1 or 2. Oh, the top is 2. So it's negative 1. So B is negative 1. So B is negative 1. And to find C, right? To find C, put x as 2 but come up this further. Yeah, it's 3. Right, so Rayson did it. And then Rayson continued the integration. How do you score out, is it? To find the B, right? To find the B, you put x at 0, you count the x. Then put all the x at 0. Guys here are very high,
No, my name is
Right. There's a minus, it's x minus ln x. Yeah. Okay. Where C is, 此处 C 是个任意参数。How to say differentiation in Chinese? That one I know. Okay. 此处 C 是个任意。Okay, good.